Welcome, Dieter. Okay, we will be changing the stage now for the Siemens case competition. And we did the case competition this year as a collaboration between Siemens, CTU, management, and Copenhagen municipality. And together we defined a case where we describe the development of Nordhavn to be the largest urban development in Denmark. It will be providing for 40,000 inhabitants and also 40,000 workspaces. So the vision of this project is to develop a future area that will be sustainable and CO2 neutral. So the students were giving presentations from both Copenhagen municipality, which is in front here, and also Carl, you remember, when he presented the ideas from Copenhagen municipality and what thoughts they had and what kind of criteria there should be in order to develop a sustainable city. And the students were given the freedom and the global rules to develop solutions for this purpose. So they should come up with ideas either to solve concrete problems or ideas that would be targeting the goal of a sustainable CO2 neutral city. Besides the presentation from Søren, do you want me to speak louder?
It's better.
Oh, okay, I think we have this one. Is it better? Yes, much better, okay. Besides the presentation from Søren from Copenhagen municipality that told about the initiative, we also had a visit from Reiner, who gave a presentation about the city of the future. And the students worked during the 3 weeks in June, which was a collaboration with DTU management and the course of Sustainable Engineering Solutions. So here's some pictures of the students working, and along with these 3 weeks, the students were given the opportunity to have some supervision sessions. We had 2 supervision sessions where the students were given the opportunity to talk with Reiner, and he was able to give them feedback on their solutions. And also Søren gave 2 supervision sessions. So the output of the 3 weeks of course in June was 30 pages assignment and also the ECTS point, and of course also the today's presentations, where you will be presented with 5 different projects and ideas on how we can develop ideas for the future sustainable city. So with these words, I would like for you to all give a hand for the first group that will talk about ABs. I think you should use these mics.
Hello? Hello?
I will be timekeeping. Strictly.
Okay, I think we're ready. Yes, we have this project called ABs. I'm Kai. And
I'm Frederik.
And this is our group from the project. Our project takes place from a real-world problem. Like most innovations, this is very important to us. 1/5 of the Danish population, like 20% of the population in Denmark, actually feel the consequences of this daily problem on an everyday basis. And almost 120 million people in Europe is feeling the same consequences of allergic reactions because of pollen. And not just pollen, but air pollution in general. Like you see in this picture of Tokyo, you can't almost see anything of the city because of the air pollution. This problem we're trying to solve by our solution, which combines technology and biology in a whole new way. Our project is called ABS.
Yeah, and I would like to explain our approach. So we have three things in our system. We have got the drones, which you see here, the cube, which is the base for the bees, which you see upside here in the light stand, and then we got the light stand as well. The light stand and the cube is kind of like just to explain that our solution is human friendly. Of course, if I told you guys that we are making some drones that can collect pollen and unwanted particles in the air by flying around, a lot of people will think that, hey, well, that's kind of weird and we don't like that in our green gardens, etc. So we have constructed these small, we have get inspired by a project that has constructed these small drones. As you can see, the body here is it's got the electronics. So we need to have two motors to control the wings, which are very complex because normal flies and bees, they have special material of wings so they can fly, of course. And we got the electronics to control these motors and also to communicate with a larger bee, which we call the master bee. So when the bees are flying around, they are flying just like this. And inside they have a rectangle of a filter, which is the HEPA filter, as we know from inside air cleaners. And also we want to have a diode light. So an example of how it will look in the evening, this is an example of small solar panels with lights, and we think that this looks very nice. So this will give an attraction for Nordhavn, and this is why we believe that it will help people to understand and to control these drones so they don't be afraid of them.
Yeah, so the function of these drones is very relevant in this new city part as well, because, well, it's a green city. There are lots of parks all around, and some of the roofs are actually covered with green. So that means that air pollution is a problem in these parts as well. So this is why we chose to make this solution in a city, which is going to be built in the next 40 years.
Yeah, just to explain, these drones, small ABs with their master bees, they fly back to the base at the top of the light stand. Here, their filters are cleaned and they are charged, so they are ready to fly again. That's just the explanation of the cube.
Yeah, I think we're done.
Yeah. Yeah. Yeah, Søren? Our thought is that it is batteries, and that's one of our huge problems as well, because small batteries don't have that long of an energy time at the moment. So we have to look into alternative energy sources, but at the moment we were thinking about using batteries, yes.
We calculated about, I think it was like 2,000 per 10 square meters or something. So it's quite a bit. But if you think of them like if they get optimized in the future, we guess that it is a possible solution if we change every light stand in Nordhavn with these ABs.
If I just comment on that.
Per 10th.
Yeah, we were thinking about having not the ABs flying around in the height of like this, but 4 meters above the air and then 6 meters in total. So 10. We were thinking about.
Yeah, about.
Yeah.
Uh-huh. Yeah. We tried to solve that problem by moving the airbase area by like 4 meters above the ground. So you don't recognize the sound of this because it's high above our heads.
We discussed at what time of the day we wanted to collect these pollens. And so we were thinking about maybe collecting them at the early morning before people get out, so we don't disturb. Yes.
Yeah. We're hoping that it will come out somehow. Yes, we're thinking about water cleaning.
I don't think we have HEPA filters we know from inside air, indoor cleaning, and these filters need to be cleaned as well. So we have to use the same method. I don't think we can answer on exactly how, but yeah.
But yeah, 2 ways to clean them would be water or by air.
Our thought is that when the bees return home, they sit around these, I don't know if you can see them, but the flat surfaces around. So you can see the bees that they are home. So then their diode will give the light.
So about in every light stand there is about 2,000 bees. So this means that 2,000 small LEDs will light up. So we guess that's effective as well.
Yeah. Son? I don't think we can answer that question because we don't know really the price of the bee.
Yeah, but if you think about the gains, like every person with asthma costs like 7,500 kroner each every year for the government. So if you add up, then yeah, the gains are maybe that big, I think.
Okay, we have to stop here. Thank you very much for the robot. Second row. Entering. Give a hand for this row as well. Thank you.
Hello. Hello, everybody. We are group Echo Tree. We are 5 in the group, but on the stage today you have the honor of listening to me, Ahmed, and Fredrik. Our problem in Nordhavn is the pollution. There are cars, of course, and then the big problem with the cruise ships that do a lot of pollution. And we have CO2 and NOx. CO2 is, of course, a global problem, so making an effort to reduce the CO2 locally does not have a big effort globally, and then NOx is a more local problem that we want to focus on. And then we have also, when building a new city, there's not living any people yet, so we have a lack of urban activities in the beginning. How can you make people live there, and when they live there, how can you make them active in the city life? For that, we have developed a tree. This is the design, Echo Tree. And the function of this tree, it cleans the air for CO2 by some resin, and then for NOx. And it has it has a playground attached to it for the energy. That's also in the other point where it's self-powered. And it's also an attraction in Nordhavn. Nordhavn right now is just as a place where people come in cruise ships, and then they go to Copenhagen directly. They don't stay in Nordhavn, and that's a problem we have to solve. But is this solution sustainable?
Well, we think that it's very much sustainable, actually, because the materials, if we could start with that, are made from polyethylene tetraphthalate, and our thought is that it's going to be reusable. That's one key point. And of course, we thought a lot about the production of the different things, and we have a pump that's very efficient. We have to pump water through the system. All in all is to make sure that the output of energy is higher than the intake of energy. And as you can see on the top, we have these solar panels, and Rainer Spee showed us some organic solar panels which actually can be formed like leaves. So people won't see these ugly surfaces of solar panels, and the whole system will actually kind of be a showing point, a political motivation for using solar energy instead of fossil fuels and all that. And actually, they're quite they're quite efficient. So the whole tree can actually produce electricity locally. And at the same time, we have this strong base resin, which is the whole system. The idea of binding CO2 by making it to carbonate form. And then you can use water to remove the carbonate, which is an ion. And then you can pump this carbonate away from the surface, and then you can do a reversible situation where you can get the CO2 out as gas, and then you can capture the gas. That's the whole point. Get the gas, the CO2 out from the air and into a tank where you can empty it into a central station or something like that, where this CO2, as Michael Wannberg said, that then you can make other things from the CO2 by using the excess energy from the grid, like toluene and stuff like that. In that way, it can facilitate other more green things. And at the same time, we have investigated the use of a NOx catalyst, which can remove the NOx from the air. But of course, we are very there's time. But there's problems with the temperature-wise things. But in the future, perhaps one day you can actually bind NOx efficiently at room temperature. Thank you. That's all. Any questions?
How many trees do you need to have impact?
Well, the calculations, it's a system. The system of capturing the CO2 is inspired by another system, but we're trying to implement it. But they said something that one tree equals 1,000 normal trees, the uptake of CO2. So you will need a lot. But it's not like we are trying to remove all the CO2 from the world with these trees. It's also kind of like an educational thing to the public where they can see on an interface, perhaps on the tree, that this tree removes so-and-so amount of CO2, which equals how many persons and so on. And so we can get a political motivation in the public to lower the output of CO2. So, but it's difficult to say.
Actually, one tree should have an impact locally, because also not only the CO2 and the NOx uptake, but also it's an interactive tree, so the people can go there and they can. I think Rainer spoke about Citizen 3.0, where they help them where the citizens themselves are helping here. And this is not a social network, but this is where they can by playing in the playground, they can make electricity and then also have an impact on the environment. A small impact, but an impact. No, it's 25 years. It's the solar panels that are the restricted material, so it's 20 to 25 years.
Well, yeah, there's a pump, but as you can see, it's situated perhaps underground because we want to capture the gas and have a gas pipeline in the water underground, so the pump in theory can be underground. And because it's it's a high efficient pump and it doesn't need to be that big, it's not a huge volume of water, I don't think it's necessarily very noisy because you can also insulate sound-wise and all that. But of course, you need to think about those things because no one wants to have a noisy thing underground.
Yeah, we tried to do some calculations, and we've calculated the cost of the materials. Not there's of course companies that will produce it; they will also have some profit, and only the materials. It would cost about in euros now 13,000 euros, 13,000 euros in materials.
13.
13. Yeah.
So I guess we can double that because we need to assemble it and transport it and all that, and that also leaves a footprint CO2-wise. But any other questions?
Yes, my name is Sebastian, and I'd like to introduce the Sustain Living System, which we believe will be a revolution in home controlling systems. So, so in the big picture, I read an article just last week that the world population used its yearly quote of natural resources in just 8 months. So how do we change this and make it into a sustainable consumption? You could develop sustainable resources, or you could develop a sustainable consumption, which brings us to our idea. The Sustain Living System, to sum it up shortly, its home controlling systems are existing technology. It's nothing new. It's proven to have an effect. The key issue with home controlling systems are that the consumer loses interest in a very short period. So how do we approach this differently was our main issue. What we came up with is we wanted to introduce a competition or gamification of the home controlling system to kind of get the consumer involved and keep them interested. So by using nudging and a new platform, which is Nordhavn, we developed our idea. So we decided to do a survey, where almost 400 people answered. And it was quite fun to see that 2/3 of the people said that they were environmentally conscious, but 2/3 of them had absolutely no idea of what type of energy they used. But also that 9 out of 10 were interested in knowing what they were using minute by minute, live feed. They were also interested in how much it cost, and getting a lot more information on exactly this area. And 8 out of 10 people did not mind being constantly monitored. So we thought this system was a very good idea. We could see that there was a need, a demand for knowledge on this area. People want the information. And we asked the parties we thought were relevant to kind of implement a system like this at Nordhavn, and they were also all interested. Plus, we have an ideal pilot project in Nordhavn, so all in all, a good idea. So from our research and our calculations, we believe by doing it this way and by getting the big data for all the new development buildings, we could save between 40 to 55%. And the good thing about this system and using Nordhavn as a pilot project is that it can be introduced globally quite easily. So all in all, sustained living is a sustainable and innovative combination of a mature technology, and the time to realize this is Nordhavn. Questions? Yes, we will put sensors in everything in the house, electricity sockets and water usage, so you can see exactly where in the housing dwelling where you're using it and how much at the time and all this. Yes. We also did an interesting calculation that we believe it will only take around 10.5 years for it to pay back its cost of implementing. So. Yes. I don't remember the exact time on that exactly, but we did make sure that it would be worth in a CO2, and also by implementing it in every new apartment, the cost of implementing will also decrease the more you build it. Well, they thought it was an interesting idea. They said, we also asked them if they had stored the data for how much they use yearly and if they can actually see how much at a given time and all this, and they could. So, and they've already had the people ask if they can get this kind of knowledge. Can I see how much I'm using at a given time and how much is the price right now? So it is actually a question they've already had before us, so something they are working on. So there's definitely an interest in them. Yep. Yeah. There's the Data Copenhagen Council. They have one, like a division that works with the big data in the Copenhagen society. So, of course, they will have some knowledge on this area and how to secure it. Also, so people can see exactly what your neighbor is using, but that you can kind of see what's the average in my neighborhood. So, and you can see your own. Yeah. Of course, there's an issue.
I think we'll welcome to Malene, who will present the fourth group.
All right. Hello. As Christina said, my name is Malene, and my project proposal is called Eco-Goods. In the near future, the area around Nordhavn will be converted to a green area, which favors parks, bicycles, and pedestrians. The roads will be narrow and difficult to maneuver. However, excuse me. But in a large metropolitan area, delivery of goods is still completely essential. This task will mostly be performed by heavy trucks, which will have difficulty maneuvering the narrow streets. Also, an increased number of bicyclists and pedestrians will be at risk at right turn accidents, which already today leads to many fatalities in Copenhagen. My solution to this problem is to redirect all goods delivery to an underground transportation system with small automatic cars. At length, this can eliminate trucks completely, vastly improving the safety and accessibility as well as the city image. And here you can see my solution. It consists of a delivery central here and 5 entrance exits. The dark circle shows a 500-meter radius in which the cars can reach their destination within 5 minutes. This was one of my focus points, as Nordhavn intends to be a 5-minute city area. That has to apply on deliveries as well. The deliveries are collected at the central first and are only delivered when a receiving person is available at the destination. This is to ensure that traffic is not jammed and keep waiting time short. The cars can only move around the transportation system clockwise. Underground, the cars run on rails, but above ground, they switch to wheels. The rails are electrified and will charge the cars so that they can run on their own reserve once on wheels. In this picture, you can see the entrance exits in the transportation system. In the docks, you can see there, the cars can join together to form a train which drive jointly to the destination, saving resources. The cars will drive by the principle invented by Google. They will be able to see a length of 2 soccer fields in every direction, which make them very safe in traffic. Here you can see a car near an exit, and as the illustration shows, the transportation system should not be a very noticeable element in the city facade. As for the design of the cars, they are built to contain 2 Euro pallets, which means they will have a length of 2 meters, a height of 1.25 meters, and a width of 1.2 meters. This small schematic shows where the cars will join to the rail system. The cars are protected from the weather, because let's face it, this is Denmark. Also, the cars can only be opened using a unique code to ensure that goods are not stolen en route. This solution focuses very much on the social and environmental aspect, also called livability. The system will be costly to build, but the money will be well spent for a city with no right turn accident, noise, or pollution, and with a world-class automatic delivery system. It will be seen and remembered as an ideal city. Questions? I have thought about it, but the problem is the people that are trying to build Nordhavn don't really know how many shops there's going to be. So you have to estimate that to how many shops there's going to be. So there won't be much of a wait. Yes?
What if the goods is too bulky to be placed on a Euro pallet?
That is also one of the things that has to be considered. I think that goods delivered in Nordhavn needs to be requested that they are in a standard pallet. But I am only with this solution looking at the deliveries for a shop. I'm not. It was too complex to look in if people need to get a sofa and or something else delivered. So it's just deliveries to our store. Thank you.
Jesper, do we have you in the room as well?
Det ved jeg ikke. Jeg tror, man kan sige vis, og så eller view.
Sebastian, hvor vil du af? Er du gået?
Jeg tror, hvis du kan sige view, og så bare full screen, tror jeg.
Vil du godt kontrollere det? Jeg tror også, det er trykket.
Fedt. Nu sker der ting. Okay.
Så tror jeg, du skal trykke herover, for jeg tror ikke, den der vil.
Nej, okay. Good afternoon. My name is Jesper, and we were given the task by the Copenhagen municipality to help them develop the new part of the city called Nordhavn. What we first noticed was that Copenhagen has an ambition of being CO2 neutral by 2025, a rather ambitious goal. So we thought of it that either they would have to produce more renewable energy, they would have to heighten the efficiency of what we're already using, or we would simply have to consume less. With these three areas in the back of our head, we moved on to look more specifically at the area Nordhavn. One of the two interesting things that we figured was that Nordhavn used to be a very heavy industry area and partly still is a harbor. And Copenhagen would like to keep this spirit somehow of silos and this harbor vibe. Another interesting thing is that it will be the largest cruise ship destination in Northern Europe. So thousands of tourists will arrive here every day in the future. With this in mind, we actually started looking at renewable energy. But what we quickly figured, also as Jacob talked about earlier, is that energy is not just energy. So maybe the solution was not to put up another 10 wind turbines. This is an average of a year production of energy in Denmark. The green peaks from wind energy. And what we can see is that there are these huge fluctuations on the amount of energy that we actually produce. That, of course, doesn't really match what we need. Likewise, if we look at consumption versus production, to the left we have an average consumption per hour for one day at average 40,000 residents. And on your right, we see the average production of windmills or wind turbines in Denmark. That, again, is a huge misfit. So we decided if we needed to design a smart city, we should focus on how to solve this problem. We looked at energy storage, and as we also learned a bit earlier today, there's not really any really good from an economic perspective, solutions for just storing energy. But what we then thought of is, what if we combine this thing of storing energy and also adds other values? So we looked at awareness, because we didn't even knew that it mattered if we used the energy at midday or if we used it at the evening. But if we could somehow communicate this to the citizens, it would also add in value. Thirdly, that is not written here, we also thought of the fact that we have a whole new city. Maybe we should try and create some kind of landmark that can, for the thousands of tourists arriving here, represent the green Denmark that we would like to have, such as a brand. So what we came up with was, I think it says the blue tower here and the green tower there, but a huge tower made of acrylic that basically, hopefully, will become a trademark for Copenhagen. For the thousands of tourists arriving by the seawater, they can see this high tower from the seaside. And what it will do is that it will be a symbol for the green area, because for the citizens of Nordhavn, it will become a way of creating awareness of their energy usage by becoming a storage of surplus energy, basically with hydroelectricity. So we are using known technology, and our idea is that once there is a surplus of green energy, we will simply pump water into this giant tower, and that way all the citizens of Nordhavn will be able to see that right now we actually have a surplus of green energy. And once it's about to peak hour, we will simply use the water height to generate electricity. Of course, there's a minor catch. There's a reason why there are not so many hydroelectric crafts here in Denmark. This acrylic tower is 100 meter tall and dug 100 meter below ground in order to achieve an output of 8.6 megawatt hour, assuming 80% efficiency. And as I also said earlier, we knew that this, purely looking on an energy perspective, would not be the best investment. This is roughly, from numbers of how much energy is used in apartments, will roughly cover 10%, so to speak, of the energy consumption of Nordhavn, 10% of that for one day, for one cycle. So basically we are thinking of filling this tower twice a day, and so by we can kind of help out with the peak. So it's not a long-term storage, it's a short-term storage, but the important thing is that it also has these other functions. So basically our solution would hopefully become a trademark for not just Nordhavn, but for the whole area of Copenhagen and Denmark. Will create awareness of at what time of day you should use your energy, and it will function as an energy storage. Thank you. Questions? Yeah? Yeah, so you would like use, like already now there are silos where old silos are used for offices on the outside, you mean like that? Actually we hadn't, but it's a pretty good idea. We've thought of putting a restaurant. Yeah. We thought of putting a restaurant in the top, but I think it would be a more brilliant idea to use the height for actually creating great buildings. Even though the fact of, I mean, we had the idea that you should be able to see the water level, and somehow that will be lost, at least on how you're doing these buildings, if you plaster buildings on the outside. But it's, yeah. Yeah, sadly, potential energy has the height squared, so to speak. So the higher we build, total difference, the more energy. So if we have two towers at 100 meters below or above, we will not have any near as much energy if we have just one tower 100 meter above and 100 meters below, because the amount of energy we can store once it's moved up further will be higher. Yeah, but it's oh. Okay, in that case we might have miscalculated. Yeah? I don't think we considered putting on pressure. We thought of using another liquid that was heavier, like just filling it with salt, basically, but that would probably tear off our construction. But yeah, pressure could also be a way of doing it. And we also thought about some kind of combining thermal storage, like, but then we'd have the issue of somewhat isolating, and I don't know, but it's yeah.
Can you hear me? Yes. Okay, for the next 20 minutes, I would like for the jury members to go on back the stage and vote on which groups that you think would be having the most relevance and should have the final award of the money prize and also the field trip for Berlin next year. And the rest of us, we can enjoy ourselves and have some coffee and fruit. And I don't know if there's any more ice cream.